Hello, Physics 15 class. Okay, we're going to do the homework for Chapter 3. Let's go over that. Come up to here. Go there. Okay. That looks pretty good, I hope. So, first homework problem is E2. This is on page 57. A large rock is dropped from the top of a high cliff. Assuming that air resistance can be ignored, right? Because air will impede acceleration. You know, if you're driving in a car, stick your hand out the window, right? If you're going 60 miles an hour, you can feel the air resistance. That's a lot of resistance. Okay, assuming that air resistance can be ignored and that the acceleration has a constant value of 10 meters per second squared. Yeah, the book likes to approximate 10 meters per second squared. You know, I like using 9.8 meters per second squared, but we're going to you know, do the problem as it is. So they're saying the acceleration. Now this is the acceleration of gravity at the surface of the Earth. It's always 9.8 meters per second squared. It's just what it is. If you go to different planets, go to the moon, it's different, it's less. If you go high up in the sky, the force of gravity is less, right? If you go really far out into space, the force of gravity is less. At the surface of the Earth, it's 9.8 meters per second squared. But we're gonna go with the book here, and it's saying acceleration. Well, we're gonna say g, because this is acceleration, but it's the acceleration due to the gravity. Okay, and we're gonna say it's 10 meters per second squared. Okay, how fast would the rock be traveling 6 seconds after it was dropped? So time, I'm going to use a script T. Later on, if I have pluses, you won't get my pluses and my T's mixed up. So time is equal to 6 seconds. Okay? And then after that, we're going to convert to miles per hour. We're going to do that as well. So, and what we're looking for, the question is, how fast would the rock be traveling 6 seconds after it is dropped? So it's looking for the speed, the velocity. We're going to say velocity. It's going down in a straight arrow, right? And that's what we're wondering. What is the velocity? Okay. Well, we know from the previous chapter that velocity is equal to acceleration times time. This makes sense because time will be in seconds. It's going to cancel out. It's going to cancel out one of the s's, you know, the s squared. From the acceleration, we're going to have meters per second. So already you can see that the units work out well. And let's just call this g. And g is for the force of gravity, but it's the acceleration due to the force of gravity. We're going to call it gt just to distinguish it. Okay. And we're approximating as 10 meters per second squared. When you approximate, instead of saying equal, you do a squiggly line. So we're approximating this as 10 meters per second. This shows like, hey, we're just kind of getting it close, right? So, okay, so that's 10. So V equals GT, so it's going to be 10 meters per second squared times 6 seconds. Now, the seconds here cancels with the squared here, and then you go 10 times 6 is equal to 60, and what units are you left with? Meters per second. Voila. That's your answer. Yeah, the universe is amazing. You can do math and you can accurately figure out how the universe works. Pretty neat stuff. So let me just go like this so you can see it well. Okay. So we see that. Now the second half is they want us to convert it to miles per hour, because right now we're meters per second, right? A meter is a little bit more than a yard, right? That's a meter. A second, we all know what a second is. Well, we're going to convert it to hours as well. So if you go to your appendix in the back of your book, Appendix E, it gives conversions. And the conversion that it gives for 1 meters per second is equal to 2.237 miles per hour. Can you see that in the camera? I think you can. Okay, miles per hour. So now we're going to convert. We're going to solve. So what you do is you just set up a proportion. So watch how I do this. 2, and you don't have to do it this way. You know, the book does it a slightly different way, but you know, this isn't Common Core. I don't care how you do the math. Do it any way you want. I'll figure it out. 2.35. Okay, miles per hour. Miles per hour is to 1 meters per second. The way what we're looking for is x. We're going to solve for x in miles per hour is to 60 meters per second. And 60, that's our velocity we got from the first part of the homework problem. Our answer was 60 meters per second, okay? Now we're going to solve for x. Okay, I'll write it a little bit neater now. So we're going to solve for x. So all you do is you multiply both sides by 60 meters per second. So x in miles per hour is equal to 2.235 miles per hour over 1 meters per second times 60 meters per second. Okay, we'll put the parentheses there. Now your meters per second cancel out, right? So this meters per second cancels out with this meters per second. And then you multiply through. So 2.235 miles per hour, right, times 60. Equals 134.1, right? The only units left are miles per hour. See, that works out. Miles per hour. Okay, can you see that? Let's put it there. Okay, folks.